am a PCB rock star. Oh yeah, I ride around in my engineer limo, get the best tables at all the engineer restaurants. It's a great life. I certainly don't need to simulate my designs. My placements are perfect, my routing is divine, and I never ever have to respin a board. I wear the nicest... Okay, wait. I almost never have to respin a board. I mean, there were those few times that I guess technically we had to respin a few times, but those were some tough timing problems and those differential pairs and... totally not my fault. I told my boss so, and I'm pretty sure he agreed. And then, who would have known about that crosstalk issue? I mean, nobody saw that coming. There were also that one time I figured out a couple months into production that I could have made a board a lot cheaper, but you can keep that a secret, right? Hi, I'm Amelia Dalton, host of Chalk Talk. Even though we may be board design rock stars, we should still use the very best tools available to us. And that means simulating our board designs. That way, we get to keep being rock stars. My guest today is Jim Martens from Mentor Graphics, and we're going to chat about rocking some simulation and analysis with Mentor's PADS tools. Before we get started, I want to remind everyone that you can click on that Download Now button below your player. There you can download a free white paper that further expands on this topic. Welcome, Jim. Thank you so much for joining me today.
It's great to be here again today.
Okay, so a lot of us do not simulate our board designs, and most of the time, everything goes just fine. So, Jim, why should I? Isn't that just more work?
That's an easy one. With development schedules shrinking and designs becoming more complex, everyone is starting to see the value of simulating virtual prototypes to save time. Simulation helps you catch critical issues early in the design process, preventing costly mistakes. In fact, by using analysis verification to reduce prototype spins, you can save upwards of $20,000 per design iteration.
Wow, okay.
Virtual prototype, which is simply predicting your design's real-world behavior by using software instead of going to the test lab with a prototype, has become more mainstream because it saves both time and money. Using IC guidelines as your only source of design parameter information doesn't let you make changes or optimize your system with confidence. But if you can experiment by changing component types and content, such as reducing the need for decoupling capacitors, you can avoid designing to the maximum parameters suggested by IC guidelines. Approaches such as this can use less board space and lead to reduced layer counts, which introduce cost savings.
Sure.
Through simulation, you can identify which circuitry dominates your system, allowing you to focus your efforts on reaching and maintaining signal integrity in your critical areas more quickly.
Yeah.
For each stage of the design process, there are simulation analysis tools that can help you choose the best parameters for your board, define necessary constraints, select the optimal set of components, and ensure effective placement and routing. These tools are in areas of signal integrity, power integrity, analog, thermal analysis, and 3D simulation and analysis.
Yeah, okay. So simulation is great. Do I really need to simulate from the schematic?
You should. From the schematic, you can perform what-if analysis of your critical nets using existing attribute and design data. This simulation can be done before the board is laid out. With the results of the what-if analysis, you can create a termination scheme and identify critical design parameters and component values for the net you are currently analyzing.
Oh, okay.
Pre-layout signal integrity simulation in PADS allows you to choose a section of circuitry and automatically bring it into the simulation tool for what-if analysis. You can try different values for trace lengths, experiment with traces routed on internal versus external layers, modify layer stack up, and try substituting different components. By choosing the correct combination of parameters and constraints, you can ensure the optimal performance of your design. Another huge time saver in PADS is the termination wizard, which will recommend and assign the best termination strategy and values for that signal.
Very cool.
With the results of crosstalk simulation, you can proactively identify spacing requirements that will ensure your design will be routed properly, avoiding unwanted respins. PADS pre-layout DDR analysis easily and efficiently analyzes nets and derives routing rules for data and address buses.
Okay, so I can see the schematic simulation gives me a lot here. Is there something else I can do to ensure my PCB will work properly?
Yes, let me show you the benefits of a layout-driven simulation.
Great.
Once a PCB has been routed, you can run simulation on a virtual prototype of your board to verify the signal integrity of your traces before sending it to manufacturing.
Okay.
Pads provides the ability to automatically extract the geometries of a routed net to generate more accurate waveforms and to determine whether routed traces have any signal integrity issues. Signal integrity checking is performed for overshoot, undershoot, ringing, crosstalk, timing, signal quality, eye diagrams, and bit error rate. You can analyze the whole board or just your selected critical nets to ensure they meet your criteria.
Very cool.
By basing its results on real routing, PAD's post-route signal integrity analysis allows you to refine values for termination components. You can add additional terminators or remove obsolete terminators, thus optimizing the design.
Okay.
Other variances in design components can be simulated to account for availability and differences in parameters between manufacturers or component revisions. This approach gives you maximum flexibility in choosing the final set of components to reduce costs.
Okay, so what about my power distribution network? In the old days, if I had myself a power layer and a ground layer, I was just fine, thank you very much. But things are getting a whole lot more complicated. What do we do about power planes?
You're right, it's not uncommon to have a split with 12 to 15 planes because of the power rails from today's components, which are designed for low power consumption.
Right.
So fast feedback on plane design will increase productivity and quality without adding to your development schedule. After placement is finalized and planes are designed, but before routing, it's a good practice to check the power integrity of plane areas. After routing, run your power integrity checks again to confirm that newly added vias haven't introduced power issues.
Right.
PAD's power integrity checking provides information to avoid voltage drops and current density peaks. When checking for voltage drops, you can review batch results for pins out of tolerance to ensure you have sufficient power. For current density, you can identify hotspots from insufficient copper areas that can lead to field failures.
Okay. So what if my design needs to go really fast, like 5 gigahertz or more? I assume we have to do some special stuff there, right?
Well, on average, we are seeing 5 to 12 gigahertz designs in production. Maximum production designs vary from 5 to 20 gigahertz. There are even design prototypes that range from 25 to 28 gigahertz.
Wow, okay.
Moving towards clock speeds of 5 gigahertz per second beyond, every piece of interconnect will make contributions to the signal at the receiver end. The use of differential pair vias is increasing. Vias can cause signals to be out of sync, especially when high-frequency clocks are in use. PAD's 3D simulation provides increased accuracy compared to 2D methods.
Okay.
3D simulation is part of the gigahertz hyperlinks option.
All right, let me get my 3D goggles on. Welcome to Chalk Talk 3D, ladies and gentlemen. Okay, Jim, let's wrap this up. I've got some simulation to do.
Amelia, you can take away the 3D goggles. They're not needed here.
All right, fine.
So from today's presentation, the takeaways are, the effects of increasing clock speeds make simulation a requirement and not an option, even in basic designs.
Mm-hmm.
You can significantly reduce respins through the use of simulation analysis, saving you time and money. Pre- and post-layout analysis not only help you achieve and maintain signal integrity, they can optimize circuit implementation by providing flexibility in design constraints and component selection.
Okay.
The high level of integration between PAD simulation analysis and the layout and schematic support a level of ease of use and accuracy that is without peer, as you have the ability to automatically extract PCB geometries and seamlessly pass that data.
Okay.
PADS and Mentor Graphics delivers this functionality and more. If you want to try it yourself, log on to our virtual labs or download the full PADS ES suite and try it yourself.
Okay, fantastic. I think I will. Thank you so much for joining me today, Jim. It's a pleasure speaking with you.
Always a pleasure to you, too.
And before we go, don't forget to click that Download Now button below the player to download a free white paper that further expands on this topic. For Chalk Talk, I'm Amelia Dalton. For more Chalk Talks, check out the on-demand section of eejournal.com.